Hello everybody, welcome to this tutorial on how to use your calculator to find zeros of a function. It's quite simple actually. You have to graph the function and then you have to basically ask it where it crosses the x-axis. There's a key, those are what we call zeros. There's a key that does it for you, you just need to know where to look for it. To start out with, let's start out with a function. Let's start out with a very basic function. We'll start out with y equals 2x plus 1. So we push y equals on our calculator. 2 times x plus 1 is right here. And we should be able to find this in a standard window pretty well. If I push zoom 6. It is kind of important to see where it crosses. Now, because of it's sort of close there, it makes me think that this might go through 0, but when I look at the equation I know better because the y-intercept is positive 1. If it went through 0, 0 on the x-axis, this would run 0. So maybe a better window is in need here. Maybe if we change this to, instead of -10 to -2, and positive 2, and have this go in jumps of, say, 0.5. And we'll do the same for the y-axis just to see what it does. -2 and positive 2 in jumps of 0.5 or scale of 0.5. Okay, that looks a little bit nicer. We can see that there's a nice spot right there where we cross the x-axis. That's what's known as a 0. Have the calculator find the 0 for you, what you're going to need to do is push second trace, which is calc, and right there it says it, 0. You can arrow down to 2 and push enter, or you can just go here and push the number 2. You don't even have to be on it, and it'll give you this screen. And what's the question mark here is left bound. And what that means is they want you to move this blinking cursor to a spot that is to the left of the point. So this blinking cursor right now is to the right of the 0 point that we're looking for. So what I need to do is move it to the left of the 0. And then you push enter. And it draws a little arrow up here. It says, okay, the calculator decides we're only going to look for these zeros in this spot. And then the next question says right bound. So you need to move the cursor somewhere to the right of the 0. And you push enter, and it puts another one. So these two arrows pointing each other means on the x-axis, or the domain, this is the piece of the domain on the x-axis. That's the only place where it's going to look for zeros. And then it asks you to guess. Guess where you think the 0 is. So right now, just moving my cursor, I think the 0 might be at -0.468. Let's see what it's exactly. Once you move it to where you think the guess is, you push enter, and you'll see that the 0 is exactly -0.5. That's where it crosses the x-axis. That's where y equals 0. But why even have this feature at all? I mean, lines, by their very nature, only cross in one spot. They can only do it. They don't curve back down and cross in two spots. So why do I have to say I could just tell it, find the 0, it's a line. Because everything that we make in class, or everything that we're going to be interested in that might have zeros, isn't necessarily linear. For later on in the class, we might look at things that are like this down here, where it goes up, down, and so forth. This is a 5th degree, something that has the highest power of 5. And it could possibly have 1, 2, 3, 4, 5 zeros. So things that are 5th degree could possibly have 5 zeros. 4th degree could possibly have 4 zeros, and so forth. The degree does match the number of possible zeros. Not the absolute number of zeros, but there could be that many zeros there. Let's take a look at this example. Here's an example that I'd like to graph on our graphing calculator. So we'll put it in the y equals, just the way it's written. That's how you put things in your graphing calculator. It's written like this. You find the parentheses, the x minus 2, parenthesis, another parenthesis, x plus 3. And if I push graph, well, I don't see something. But if you remember, we switched this up. We changed the window to be this. Let's make the window different. So let's start back with our standard window. We'll start back zoom 6. Oh, and that's a pretty good window. So what are the zeros for this function? Let's build off of there. The function, to find the zeros, you push second, calc, push the number 2 or arrow down to 2, and it asks for the left bound. Let's find this 0 first, the one on the left. So for a left bound, we need to move that cursor, the blinking cursor, somewhere to the left of this 0. And when we push enter, it says, okay, there's a little arrow. It's harder to see in this case, but it's going to look to the right of that. And then we got to go somewhere to the right bound. And that looks like a good spot right there. Push enter. And then it's going to look somewhere in between here on the x-axis is the 0. Then it asks us to guess. Well, our guess looks like, that looks like a pretty good guess, negative 2.978. What do you think? You think that's going to be 2? I do. But we push enter to get the exact number. And that gives us the, oh, I'm sorry, 3. Yes. We push enter to get the exact number. And this is going to be negative 3 right there. All right. So one of the zeros is negative 3. To find the other 0, you have to do this whole process again. You go up and you arrow down to 0, enter. Okay, this is probably a good enough spot to put the left bound, but I'm just to make a point, I'm going to move it over, you know, because I like to, and I'm going to make less work for the calculator. I'm going to say the left bound of the point that I'm looking for is right here. I push enter. The right bound of the point that I'm looking for is somewhere over here. This is somewhere to the right of the point. I push enter again, and it gives me that interval. Asks me to guess where I need to put this. And it looks like it crosses here. My guess would be 1.91. What do you think? It is 2 this time, right? And push enter. That's my guess. And hey, look at that. It is 2. You know, you can use the trace feature on this, but sometimes these equations that I've shown you are very nice and neat equations. If they're not nice and neat equations, those decimals might actually be the right spot where they cross. That's why it's so nice to have the zeros function. It gives you the exact place where, when y equals 0, x equals whatever we're going to call the 0 is.